Hello, everyone. Thank you for coming to my presentation. My project is about comparing two neural network compression techniques called product quantization and binary weight networks on several standard benchmarks. First of all, let's talk about the motivation of compressing a neural network. Neural networks has been dominant in many important application problems that require complex domain knowledge to solve, such as image recognition, computer vision, and natural language processing. The challenge is as neural networks complexity growing fast, it brings significant computation cost. One solution is to use model compression technique to simplify the neural networks. This technique includes weight compression, network pruning, and many more other alternatives. Today, my topic is about weight compression. But how can we compress neural networks' weights? Is there any price to pay? The answer is yes. Compressing a network may cause extra computation in the forward and backward step in training. It may also introduces loss in performance, for example, in terms of accuracy. But what is the gain? The gain is huge. It includes a faster forward step in training, a faster inference step. It may also avoid relying on several new types of hardware, such as accelerators. And we first start with one popular approach to compress neural network weights. This approach is called product quantization. The basic idea is to reduce the space of the weight vectors. For example, we can treat the original neural network weights as a n by m matrix, which is also n m-length column vectors. And for each column vector, we can map it to a most similar m-length vector in the codebook. So codebook is a collection of m-length vectors of the same size. So in this way, this matrix is converted into a vector of integer of size n. The compression rate is therefore n. And the second approach is called binarization. As its name indicates, it simply converts a real value matrix into a 0-1 bit value matrix. So in this way, the compression rate is 32 because for each float real value that takes 32 bits, it turns into 1 bit. And I run the first experiment I run is on MNIST, and I compared these two approach in terms of compression rate and accuracy. So the result is in the table. And I also run the same benchmark on Tiny ImageNet, which is a subset of ImageNet. And we see that the accuracy result, compression result, is different from what we had in the previous experiment. So let's go to the conclusion. The conclusion is on MNIST, both model performs great. This is because the complexity of the task is low. And on ImageNet, both model has a drop in its performance because the task is much more complex than MNIST. However, the product quantized network has significant better accuracy than a binary one. In terms of compression rate, both methods provide a very close compression rate. So my conclusion is binarization does not need GPUs, so it's more suitable for easy tasks on resource-limited devices, such as embedded systems. And a product quantization is a more suitable approach for difficult tasks when GPU is available. This is because of its real value property. So this is my work. Thanks for watching. Right now is the Q&A time.